Hi everyone, I'm Cheryl. In this problem, we're given a solid bounded by the plane 2x plus 3y plus 6z equals 12, x equals 0, y equals 0, and z equals 0. We're asked to find the mass of that solid and the x-coordinate of the center of mass. Well, first let's take a look at the picture of my solid to get an idea of what's going on. So I know that I have the plane 2x plus 3y plus 6z equals 12. Let me solve that for z first of all. If I solve this for z, I'm going to end up with 2 minus 1/3 x minus 1/2 y. And looking at this, if I let y equals 0 in the xz plane, I'm going to have the line z equals 2 minus 1/3 x. That's going to give me a z-intercept of 2 and an x-intercept of 6. So I can draw in this line. If I let x equal 0 and I take this term out, in the zy plane, which is this plane, I'll have the equation 2 minus 1/2 y. That will give me a line with a z-intercept of 2 and a y-intercept of 4. So I have this line drawn in. And then finally, if I let z equal 0, I have the line 2 minus 1/3 x minus 1/2 y. That's in the xy plane with an x-intercept of 6, a y-intercept of 4. And so I'll draw in this line. So this little triangular piece shows me the part of the plane bounded by x, y, and z all equal to 0. So it's that solid that's created in that first octant. All right. So what I'm trying to do first of all is to find the mass of that solid. So we know that the mass can be found by using a triple integral. So the mass is a triple integral of the density function dV. Okay, now I know what my density function is. It was given to me as just a constant k, so that much I can just enter in. So that will be k. And now I have to decide what order I'm going to integrate. So I'm going to choose this time, I'll start with my dz first of all, and then I will do dy dx. And again, you can change whatever order you like. It's just going to make a difference what those limits of integration are. So let's take a look first of all at my limits of integration for dz. All right, so I'm going to go from 0 up to this particular plane. So my limits of integration are 0 and 2 minus 1/3 x minus 1/2 y. Now, for y and x, what I've done is I'm going to take a look at this piece that's in just the xy plane. And I'm going to draw this on just an xy axis so it's a little easier to see. So it's going to look just like this if I were to draw it just in an xy plane. Okay. Since I've decided to change y first, what I'm doing is using a vertical representative element. And I'm changing y first. And then eventually I'll change x. So if I do it this way, what are the limits of integration for y? Well, I'm going from 0 up to this line. Well, what is that line? That line is y equals minus 2/3 x plus 4. So my second set of limits of integration will be from 0 to minus 2/3 x plus 4. Okay. Then finally, I have to move from 0 to 6 along the x-axis because I'm integrating with respect to x. That's the easy one, just 0 to 6. Okay, now I have my triple integral set up. I need to begin integrating. So let's start out with the inner piece. So I have the integral from 0 to 6, the integral from 0 to minus 2/3 x plus 4, and I'm integrating k dz. K is a constant, So that's going to be kz. And I'll evaluate that from 0 to 2 minus 1/3 x minus 1/2 y. And I still have my dy dx. Okay, now I need to plug in my upper and lower limits of integration. So I have the integral from 0 to 6, the integral from 0 to minus 2/3 x plus 4, and I'll have, actually, you know that k is a constant. I can pull that right out of the entire integral because it's a constant. So when I plug in my upper limit, I'm going to have 2 minus 1/3 x minus 1/2 y. And then I have to subtract what happens when I plug 0 in for z, but that's just 0. So I've got dy dx. Okay, so now I am ready to start the next integral. Okay, so I'm going to move this up. And I have that constant k that's on the outside, the integral from 0 to 6, and now I'm going to integrate this with respect to y. So I'm treating x as a constant here. So 2 is a constant, so that integral will be 2y. And then I'll have minus 1/3 x times y. And now a minus 1/2 y squared divided by 2. And that's going to be evaluated from 0 to minus 2/3 x plus 4. And I still have my dx. Okay, so now let's take a minute and just simplify this just a little bit. So I'm going to have 2y minus 1/3 xy minus 1/4 y squared, evaluated from 0 to minus 2/3 x plus 4 dx. All right, now I'm going to plug in my upper limit, and I'll have k times the integral from 0 to 6. Remember, I'm plugging this in for the y values, so this will be 2 times the quantity minus 2/3 x plus 4 minus 1/3 x times the quantity minus 2/3 x plus 4 minus 1/4 times the quantity minus 2/3 x plus 4 squared. And then I need to subtract what happens when I plug 0 in for y, but luckily that's all just 0. And so I still have that dx written. All right, so now we need to simplify this integrand. So I'll have k times the integral from 0 to 6. Distributing the 2, I'll have a minus 4/3 x plus 8 and a plus 2/9 x squared minus 4/3 x. Now here I'm going to need to use FOIL and then multiply by a negative 1/4. So using FOIL, this term will give me 4/9 x squared. The 4's will cancel, and I'll have a minus 1/9 x squared. The outside and the inside terms will both be a negative 8/3 x. So that gives me a negative 16/3 x, which, multiplying by 1/4, will give me a plus 4/3 x. 4 times 4 is 16, times 1/4 is 4, but remember that negative, so I'll have a minus 4 dx. Okay, so now let's go ahead and combine some like terms. I'll start with the x squared term. So I have k, the integral from 0 to 6. I have a 2/9 x squared and a minus 1/9 x squared. That's going to give me 1/9 x squared. I have a minus 4/3 x, another minus 4/3 x, and a plus 4/3 x. That's going to give me a minus 4/3 x. And then I have an 8 and a minus 4. And so that's going to give me a plus 4 dx. Okay, I'm all simplified, so I'm ready for the next piece of the integration problem. So I have k times 1/9 x cubed divided by 3 minus 4/3 x squared divided by 2 plus 4x. And that will all be evaluated from 0 to 6. So plugging in the upper limit, I'm going to have 1/27 times 6 cubed minus 4/6, or you could write that as 2/3, times 6 squared plus 4 times 6. Now I have to subtract what happens when I plug in the lower limit, but that's just going to be 0. If you do the arithmetic for all of this, you're going to end up with an 8k. All right, so that's the mass. The next piece of this puzzle is we were supposed to find the x-coordinate of the center of mass. And I know that I can find the x-coordinate of the center of mass by taking the moment about the y-z plane and dividing that by the mass. Now, we've already found out what the mass is. That's an 8k. So what I need is the moment about the y-z plane. So how do I find that moment? Well, the moment about the y-z plane can also be found using a triple integral. So we're going to have a triple integral again. But this time I want to take that density function and multiply it by the distance to the yz plane. The distance to the yz plane is x. So I'm going to have x times my density function, and then I need to set up my order of integration. I'm going to use the same order that I did before, so that's dz dy dx. And the reason I want to do that is that now all my limits of integration are the same as the limits of integration from before. So I'll be going from 0 to 2 minus 1/3 x minus 1/2 y. For my second set of limits of integration, I'll be going from 0 to minus 2/3 x plus 4, and finally from 0 to 6. We can do this triple integral in the same way that we did the triple integral for the mass. Again, remember, starting with the inside, moving to the second integral, and finally doing that last integral. If you go through the calculations for that triple integral, you're going to end up with 12k. All right, so that means I can put 12k here, and the k's cancel, and I have 3/2 for the x-coordinate of my center of mass. I hope that was helpful. Thank you.